So that means that from negative pi on 2 to 0, this graph should look concave up. So it should be, when it's increasing here after the negative pi on 3 location, when it begins to increase, the whole thing should look like it is something like this, right? A concave up kind of looking way. And we had an inflection point at 0, 0. Right? So we need to make sure that it changes from looking concave up here to concave down here. Okay? So concave down until this. Right? Concave up before. It's not the best looking, but you get the idea. Okay? And this point over here, since f of negative pi on 2 is negative pi on 2, and the function is odd, so that automatically implies that f of pi on 2 must be pi on 2. All right, just change the sign. So again, a little bit past 1.5, so maybe right about there. All right, and it should be decreasing from this relative maximum down to that value. But all of this should appear in a concave down sort of way. So there's our inflection point here. Okay, so now we just have to label everything in some sort of reasonable way. We know this end point here is pi on 2, comma pi on 2. This was negative pi on 2, negative pi on 2 over here. All right. I have 0, 0 as the inflection point. Something like that. I'm not going to label these. It's just going to get messy because of how terrible the values were for the relevant extreme locations. But all in all, that's takes into account everything that we learned from the first derivative test and the test for concavity and inflection points, and incorporates it all into this particular graph of f. This should be about what it looks like probably if you graph in your calculator. But I mean, of course, you know, it will extend beyond this somehow, right? But just between negative pi on 2 and pi on 2 inclusive, this should be a pretty good representation of what the graph looks like.